Okay, hello everyone. This is my third live stream today. All right, new topic. This is Wolfram language design review, incremental language development, and we are looking first at threaded, a new capability. Oh, we're reviewing documentation for that. Okay, and we're actually going to be able to review threaded in the wild. Okay.
So I think the main thing here is that this is such a special creature, and so its documentation is also a bit special.
I think one thing to start mentioning with this, our documentation of Listable is non-existent to appalling. I mean, we know what we mean by Listable, but I think users get quite confused by it.
I don't like using this as an adjective. We should say for any function f with attribute listable or something, or with listable with a low, just a word. So are there any design issues here? I mean, are you asking for help in the documentation, or I mean, I don't know if there are diagrams that would help here.
So the diagrams, so we are trying to explain the second argument of threaded, and because it refers to a level of the other array, we have these diagrams. There are 4 diagrams there in which we try to align the level at which we represent the threading. That's the double arrow there.
Gosh.
Yeah, these are things that Tim would have to have a whack at, but.
Is there any tensor index notation that would be helpful?
There are examples further down comparing, for example, with table. In properties and relations, we have several examples.
Don't do matrix form. Really don't do that initially. Don't do that initially. You can do that as a second example, but this is plenty useful without matrix form. Make sense?
Yep.
Which matrix form are you objecting to?
Both.
Both.
I would just do it. Look, I would do this. I would do.
I always have to check how the what matrix form means, like how the lists map to the columns and rows and so on.
I would just do that. That should be the first example, in my opinion. In fact, I'll even put it in if you want.
Sure, put it in.
I mean, I'm not going to put in the words yet, but I mean, don't get. No, this is crazy to show that as a. I mean, no. I mean, no. Those are way too complicated. I mean, you should show this. You should show the fact that it. Maybe you should show one where you could show by comparison, you could show AB well, actually what you could show is ABCD plus XY there, showing that it's different. And then you can go on and show, and maybe you want to do something where we go, maybe what we want is actually 1, 2, ag, 3, 4, 5, 6. And then we show, well, we can't show plus XY, but then we show plus threaded, simple things like that. Perhaps that's the best initial example to show.
Yeah, I think with the different dimensions is better to show.
Yeah,
I agree.
Okay, so but then here, maybe what we want to do is to take that thing and show that you have to add X, Y, Z to it.
Yeah.
And so on. Okay, then well, let's see.
I mean, that's basically the example that's already there, right? Only you.
You don't have to have the idea of matrices, which not everybody is into. Right? I think that I mean, this idea of rows and columns we should have next a little bit later. Maybe we should have one at slightly higher depth first, then we should go to that one. And that's not even close. That's an application example of some kind.
Yeah, I'll move that to applications.
Okay, now in terms of tensor arithmetic, well, okay, first question is this, are you done with the implementation, Rob?
The implementation is done, except for the sort of packed array, numeric array part, which is still being worked on. You know, Mark is going through a whole bunch of stuff in the runtime library, which is necessary to get this done correctly. So, but it's still, you know, that it still works if the inputs are packed array. It just doesn't do it optimally efficiently.
Does it unpack it, or
it partially unpacks? So if you add a big matrix to a big vector with threaded, it unpacks down one level, and it's about a factor of 2 slower than it absolutely needs to be.
Okay, so let me understand. Okay. You know, I don't think this is the right way to document this. Okay. First of all, I think it should say
yeah, I mean, I just want to say for the record, it's not that we haven't thought about it, it's that it's not so easy to figure out what the right way to say it is.
Yeah, I understand.
Yeah, exactly. And
I was going to say, you know, first thing is threaded of list represents
Doesn't it need to be an array?
well, I was thinking, okay, threaded array represents an array to be threaded into the lowest level of
When combined with
Huh.
a listable function, or
yeah, but that's
yeah, you're running into the same problem I did.
okay, hold on. But I do think that what you want to do here represents an array represents an object let's try something like this. So if we say if we said something like this, because it is always a list, I mean, that's okay. And then we said something like Okay, here's a possible term, threaded addition. Threads. Adds the elements of list into array in a threaded fashion.
Sound right. But they're both kinds of threading, right? I mean, I think we'd want to say something adds the elements to the lowest level of array or something like
Yeah, okay.
level.
Right. It seems like the first thing this needs to communicate is what the difference is between this and thread.
Yeah, and
Look, represents an object
there's
that
an interesting thing. I mean, Jose pointed out an interesting thing about the thread ref page, that we say that it threads, but we never actually define what thread means.
it was written a long time ago.
We just do it in quotes.
Well, I know that's a typical thing that we did, and it's probably the best one could do, because it's better, you know, when you give a kind of mathematical definition, it's often incomprehensible to people. You know, like you know, this first example is fairly easy to understand, but the mathematical version of that gets comparatively difficult.
Well, but I mean, that's what the details are for.
I know.
mean,
I know.
Yeah.
The details are fine to have mathematics in, but I don't think we should have the very first
that very first line was trying precisely to showcase the most important case.
I know, but I think it will be hard for people to understand with indices. I think they'll look at the examples to find sort of an index-like version. Represent is an object.
But by the way, I think thread doesn't even, in its details, doesn't even explain what it does.
Well,
Right. Yeah, that's sort of the point.
Exactly.
An object whose
Word
elements
is listable.
are automatically threaded into the lowest level of. Will be automatically threaded into the lowest level in an array when
used in listable operations.
When used in operations. By the way, it should say very early on here, it should say, in array plus threaded of list, the lowest level dimension of array must match the length of list. I don't know if we say that.
Oh, but that's only correct if list is a vector.
Okay.
I mean, the more full statement is the lowest level dimensions of array must match the dimensions of list.
Okay, I think we should try to get some diagrams of what this thing does.
Yeah, well, those excluded cells were one attempt to sort of explain how listability and threaded works, which I think if they're timified, they wouldn't be so bad. And then those other diagrams that I put in were something Jose and I discussed that try to explain where the dimensions match. I mean, they're not nice because I'm not good at typesetting and
Yeah, but
stuff.
hold on. I mean, I'm not keen on X and Y as being the different things. I'm not really even keen on using F. I would just use plus and then say it can be generalized to F. Because I think plus is going to be the very common case. It's
Plus
also,
and times, yes.
yeah, it's also important to say that it can be either way around. And it's also important, I don't know if you discussed this, to talk about the case where there are 3 arguments and things like this. Right, so I mean, if I say threaded of this plus,
I mean, I have an example in there that shows that in the scope section.
okay. What happens, by the way, if you just say,
Good question.
that does the right thing? You should show that in somewhere in some scope section.
I'm pretty sure that's shown in the scope section as well.
Something to take into account here is that when what we are threading is an array with several levels, then we are not just threading a level. We are threading all levels.
Right,
of
an
that array.
object's elements will automatically be threaded into the lowest level array. Please don't use X and Y. Just don't use X and Y. It's like super confusing. It's like those are coordinates, not things.
Okay.
Yeah, we can use A and B, for example.
That's fine. Or
Yeah.
and I wouldn't use F. I would use
R1 and R2, R being ARR.
I think we can just use A and B probably is okay. Just not X and Y. I mean, this should surely say A lev to B lev there.
Yes.
But I also think, I strongly think that it should be
Yeah, fair enough.
because I think it's going to be by far the dominant case is plus threaded.
Shouldn't
Well, I
that
think
be-
you got those two mixed up. It should
yeah,
be
it's
B
B
lev
lev
goes
to-
to A lev.
Should it?
Yes,
Yeah.
it's a,
What did I know?
well, it's a confusing thing, but it all canonicalizes to the one level specification, which is the fortunate thing.
How does it do that?
Well, because once you, by requiring that B be an array, then we can always adjust to one. One goes to lev, which is the one argument specification for lev without the rule.
I see. By the way, you should also say that basically this is a creature of, and if I make this ragged, I'm out of luck.
That's right.
Lost and found. You need a message.
Yeah, I think there is one, but I'll have to be
There
sure
isn't
that
one. Yeah.
I mean, yeah, as of Friday, I put in the messages, but maybe I didn't push them soon enough or something.
Okay, fair enough. What lovely functionality this is. Now, I have a question. I mean, are there any other kind of structures like quantity array or something that should be able to take threaded?
Well, quantity array is effectively doing its own threading already, or its own threaded. And I think there is an example further down. If quantity had a listable attribute, then quantity of threaded would be equivalent to quantity array. I think it's near the very end, probably. Yeah, this last one.
Well, should quantity have listable attribute?
I mean, I'm sure there's existing stuff that sort of relies on having like quantity of vectors without it distributing, but
Well,
sure.
no, I mean, quantity effectively threads as if it was listable. Now, the thing is, what happens if we want to have a list in the first argument and a list in the second argument?
That's why it can't be listable.
Right. Then I mean, at the moment, I don't think it supports that syntax. But if we wanted to support that syntax, the listable attribute would force us into a corner.
Yeah, right. But I mean, it could be effectively, okay. You're saying, okay, wait a minute. If I'm just trying to think of other uses of threaded that aren't directly on, well, look, I mean, already this plus thing is just huge. Well, that's probably enough. I mean, I'm just wondering whether like span and things like that, they will end up, or up to, they will end up getting all kinds of different sort of additional things. There's nothing with partition or with, what about with things like padding, like array pad and so on?
Well, I see that you are trying to use threaded inside functions that are not listable.
Yes.
So the interesting thing is, what is threaded going to be used for with things like mathematical functions, which are all listable? I cannot see where users will, cannot predict. I mean, I'm sure they would use it, but how? I don't know really.
See, already, I mean, okay, so let's say threaded. What will happen? I'm so confused what this will do. I don't even know what the heck this will do. Okay, so let's just try.
Create a bunch of different bezel functions of different orders at the specific points that
Yeah.
you. Yep.
I think we do need to work out kind of the calculus of a map thread versus threaded versus whatever, just to understand, because I don't really understand. I mean, maybe there's some weird thing you can do with outer and things like that with threaded. I don't think we've thought those things through yet.
We have explored that already a bit in the examples that are there. There are comparisons with inner, for example. This is a very interesting comparison of threaded with inner. I think it's a bit farther up. Yes, this one.
Do you really want to do that set attributes F listable? Why don't you just do plus?
We can. It's just a way of showing more generality, but yeah,
Yeah, I
we can do
understand.
more plus.
Okay. A plus threaded of V inner inner plus. Well, so you're basically saying you don't need inner because you can just do that's a much nicer way of doing inner. Is that right?
Yes. In a sense, yes. So the point is that there are some of our functions which already thread at the deepest level, like dot or inner.
Yep.
I see.
And that's why they are neatly connected to threaded.
I see. And what about map thread?
Map thread threads at the top level. So it's not.
What about combining map thread with threaded? Is that meaningful or am I confused there?
Well, we had discussed, or I had proposed at some point to generalize map thread to take negative third arguments, to do a bit of what
Yes.
threaded would do from outside.
Mhm.
Now, unfortunately, the connection with inner breaks when there is a second argument in threaded. We need a transposition. It's an interesting thing, but you see the next lines are a bit more complicated.
By the way, that might be more nicely represented with arrows. Maybe not. Not if it's that transposition, my gosh. The heck is that transposition? My gosh.
It's moving 3 levels.
Yeah.
Right.
Okay.
The last one could be written with two-ray rule, I think.
Yes. Just
Yeah,
4,
4 and 3. Yeah.
Okay. Sandra is commenting, let's see, subtract to center data. Yeah, so multiply scaling vectors and different scalings in different directions. Yes, absolutely. I mean, so the use case there, well, I mean, we can just do that with a constant array. So, yeah, this is very beautiful. I mean, we can just do this. For some reason, I'm not getting used to it yet without.
List AB.
Might be nice to detect that case and give a more sentient message. Might also be, right. For some reason, the times thing feels a lot less natural than the plus thing. Give me another listable function that I might plausibly use this with.
Power.
That's not very exciting in this case, but let's say 2.
Well, that's how you could construct like a design matrix is with.
Look at that go wrong. Yeah. Okay, what are some other examples where, what about an image processing? Are there obvious examples there?
Well, I gave that example you didn't like as a basic one, was an image. That I think is the classic case for image processing.
Very nice. Yeah. It's
You want to scale the colors.
I would not do it for a 3D image. My God. I mean,
Yeah, well, again, we can do a 2D image one too.
Right, but I do like that. I do like that. Scaling colors. It's a good example.
It's actually one thing that is nice. This is for like some properties and relations or something, but the fact that if you did that with map, you would have to write it differently depending on whether it was a 2D or 3D image, but with threaded, it's the same.
Yes.
That's a good point. I should put both in the same example to emphasize that.
Yes.
I guess maybe you could use some negative level spec, but yeah.
It's still messy. This is a good construct, but it is also a cautionary tale because it shouldn't have taken us 35 years to invent this construct.
Well, yes.
I feel like we're doing some things now with this, unevaluated expressions and this and that and the other, where we're kind of, wasn't threaded part of a larger story about arrays, or did we manage to basically boil everything we wanted to do with arrays down to threaded?
No, this is a part of a much bigger discussion about arrays, and this was our answer to sort of whole questions about broadcasting and stuff in Python, which allows people to do these sorts of operations.
Well, it's because they have the opposite definition of listable.
Yes, well, it's a slightly more amorphous definition of listable, but yes.
But
I think that array stuff, by the way, is theoretically coming back, but it's sort of been waiting for someone to, like, I think in principle there's going to be another meeting at some point, but yeah.
Well, the Future of Arrays project has branched into two pieces. One is the data container thing, and the other, I thought, was these array operations like threaded. Is there more than that in there?
I don't think so.
No.
Okay, but there's nothing beyond threaded. There's no other kind of array index manipulation thing that we have in the plan.
Well, they're sort of the opposite direction of, telling things not to list, right?
Yeah. Right. The vector. Yes, we did talk about that. The concept of a delistability. Yes,
right.
We talked about that. We need to cover that. So that needs to be in another meeting.
Yeah, Rob has some rough prototype. I don't know if it's really, worth.
Well, you've used stuff in a bunch of calculus functions, right? There are these horrifying, element of vectors 2 and things like this.
Right.
Rob, do you want to say anything about that?
Right. So we have a somewhat different design, which we've discussed with Jose and me and Roger, which we think is, and the idea, I don't want to go too far into this because it's a big topic. Threaded is a relatively easy change compared to this other thing, but we've talked about introducing something called a symbolic vector. So you'd set X equal to a symbolic vector, and then it's treated as not a scalar. And we need, to make it look reasonable, we need typesetting for that. So it looks like a, annotated X. So it doesn't look like a horrible thing.
Just call it vector. We haven't used the word vector.
Yes. Well, we thought about that. We also thought of vector and matrix. We also want an array version of it, which becomes problematic. Okay. And we want to emphasize that they are symbolic things, not actual vectors. Okay,
fair enough. Okay, so the point is that when you say symbolic vector, this is the case. You want symbolic vector plus AB. You want that to stay unevaluated.
Exactly, and my branch does that. And I think this is actually, with nice typesetting for symbolic vector. Then I think this actually looks reasonably nice. We could put in a quote X or a quote V or something in there.
Why there's a quote? We'll talk about that. Let's have a meeting specifically.
We'll have to have a meeting on it sometime. So
let's sometime soon. This is an important thing. By the way, Sandra is asking, is threaded nice and optimized? Saying before often did transpose of transpose, but that's not nice memory wise. Is threaded nice and optimized in terms of its memory usage?
Not yet.
But you know how to do that?
Yeah, the Mark is working on it. It's, you know, so for just say matrices that are not packed arrays, it's all fine and optimized. It's also optimized for sparse arrays reasonably well. But it's but the sort of the packed array and packed array case, it's about a factor of 2
Okay. So
more costly than it needs to be.
Ethan is commenting that threaded will be useful within function layers.
Yes.
Yes, absolutely. I think Julia was excited about this.
Oh yeah, because I mean, this originally came out of the machine learning group.
Yeah.
The desire to do this. All right. Okay. So anything more on threaded right now?
So coming back for a moment to your previous question of more threading, there is this function that I added to the Wolfram function repo called array contract thread, and that function has the general case of threading, and that's the function from which all other functions can be derived.
Okay.
So, I mean, it's just this question of what's the most general case of threading. And in other languages, they have a function called einsam, which has the same level of generality than this one, but they use indices and this uses numbers.
I see. So this is a generalization of inner in some sense.
Of inner, map thread, outer, all of them, threaded even.
Will anybody ever understand it?
That's why we moved it here, because it was considered too difficult when we discussed it. But my point is that if there is a discussion about of how to generalize a threading, I would always point to this function, because in a scope or properties and relations, for example, you see the, I think it's in properties and relations, you see the relations to all other functions.
Right. And I mean, the point that Jose is making is that people do use this in Python, this function in Python where it's called einsam, only rather than using numbers, you give it a string with indices and ... and it parses that string and turns it into a, you know, into the appropriate numbers based on the input. And so, you know.
Okay, so that's like a regular expression type thing where there's some kind of shorthand string form which then gets turned into something that can actually be represented more explicitly. Is that right?
I don't know that I really call it regular expression.
No, it's not actually regular expression, but it's like we have a function called regular expression where you can type in the regex syntax.
I mean, really, it's just that they've invented a syntax that isn't valid Python syntax for representing these, and that's what they're using.
Yeah.
And they're wrapping in a string.
I would say it's just indices versus numbers.
But where are the indices? How do you define what the indices?
So it's things like the string will be something like, you know, IJ arrow JI or something like that.
Right.
So contract the first guy, the first index of the first tensor with the last index of the second tensor.
Okay, but that's what you're doing. But you, instead of having an arrow here, you have a list here because you're allowing an n-array contraction.
Yeah, and counting levels rather than saying IJK goes to JJK, things like that.
Well, maybe we should have this function. I mean, we might as well have a built-in version. I mean, you know, it seems like this has already been written. Is this efficient?
It's not very efficient. This was more like an exercise of design rather than efficiency.
Okay, so the basic point is F, and these are arrays, and this is the contraction pattern.
Right. So there are several contractions potentially, and each of them is a list of numbers indicating which levels of the respective arrays are contracted.
Right. And that could probably be a graph too.
Yes, this is like a graph. Yeah.
But we could actually have a graph fed into that argument.
No, at the moment,
No,
no.
I know, no. I mean, I realize not now, but in principle, we could have.
Yes, yes. And then, for example, the G can be a list of functions because the G is like the apply at each level. It's like having a different apply at each levels. The same as inner. Inner has an F and a G. The F is naturally times, the G is naturally plus. And then these, which I call effective depths, are like the effective depths in outer. These numbers that we place at the end.
I understand. That's always a hack in outer. And it would be nice. I mean, it's kind of like a partial symbolic vector that you're saying.
Mm-hmm.
And I think when we talk about symbolic vector, maybe somebody can make sure we remember that, we need to talk about this notion of a partial symbolic vector. That is something which is to be treated as symbolic below level such and such. But above level such and such, it's still a genuine array.
Exactly.
Well, I think we should look at this function some more. And I think there might be a way of making it. I mean, actually, yeah, go ahead.
I mean, one possible direction might be to instead of allow in addition to the list of lists of integers, allow a string that's parsed and
exactly. If there's a reasonable thing to do there. I mean, also these levels, okay, something we've discussed but never okay, they're two level related things. One is the generalization of dot dot to represent progressively deeper functions in the pattern matcher. And the other is essentially symbolic level names. Like we have associations for, we have the notion of, I'm going to put this in just so we keep it. Oops.
Didn't Tally have something about that, but I'm not sure he ever finished.
He never
it.
finished
basically the thing about
he's been claiming that he has a
levels.
future calculus of array calculus, and he's been telling me he's going to tell us about it sometime soon for a while. Okay, but the concept was, okay, so here we've got first of all, we're talking about symbolic vector and partial symbolic vectors. And then we've got head repeated. Which is, in other words, what matches that? Is that what I mean? I think that's what I mean.
Yes, I think so. We had also discussed f of bracket f when we were discussing operators.
Yes.
Operator forms. I mean, not necessarily the same f, but the idea of matching a head that has so many brackets inside.
Right. I mean, so the question is head repeated? I mean, I look, I'm not sure that this is useful yet. But that's okay. Then the other thing we were just talking about, oh gosh, what were we just talking about?
Named levels.
Yes, named levels, right. Okay, so with association, we have named positions.
Right. I think the name levels could be thought of in the context of this data container thing.
Yes, I think so too.
Yep.
I mean, in a sense, association is our minimal data container.
Yep.
And yeah, okay. I mean, it is unclear what the syntax would look like for, right. Yeah, I agree. It probably has to be some kind of container because I don't see how to do it otherwise. Okay. All right. Do we have a few moments to look at
So since we have Ian and Christopher here, I thought we could potentially talk about implicit set a little bit. I know it's
Yes.
a bigger topic, so
well, I think implicit set or set builder or whatever you're calling it. Set construction. Or set construction, perhaps. I hate the word set being in there.
And we can go back to like, didn't Russell call it a collection?
But how is it a collection if it's with reals? Did he call it a collection? Who invented? Did Cantor invent the term set? And what is it? Isn't it Zahlen in German? What is it in German? Zahlen?
That means number, I think.
Oh.
Zahlen. I'm not sure, but I think that the terminology, like the term set, is surprisingly new.
Well, I mean, Cantor invented set theory. So what did he call it when he invented it? Does anybody know?
And try and look it up. But I mean, it does seem like if we had this set builder thing, there are kind of a whole bunch of functions you would expect to return it, or at least, I mean, there are things like, for example, you'd like a version of solve that returns, a set of solutions, for instance.
Yes, you would. I mean, but this is why we have this rather, I mean, that's why reduce does that by just giving an alternate set of conditions and creating variables to represent things. But it would be much better if there was an implicit, constructor. I mean, this is clearly also related to infinite lists and lazy lists and so on.
So by the way, for the naming, apparently Cantor's original paper on set theory was called "On a Property of the Collection of All Real Algebraic Numbers."
Yes,
I can try and find the
course,
German.
In the modern mathematical parlance, a collection is more general than a set.
Right? Isn't a collection?
So
like
in the
basically
pure
a
math
naive
pack that we
set?
also had class builder, where you didn't have domains for the variables.
That's obscure.
Yes, it is. But strictly speaking, you can't have a proper set builder notation without having domains for the variables. The axioms define sets in terms of subsets of existing sets.
If you believe in the whole axiomatic thing. But okay, but I mean, this is surely deeply related to infinite lists, because these are essentially lists whose elements are being generated by some kind of function or generator or criterion.
Well, lists have multiplicity and an order.
Yeah, they have an order, and to me, that sounds countable. Maybe that's
Okay, all right. But so this is compare. Okay, so compare to infinite lists, which are ordered and countable. I mean, these could be countable too. They could be over the integers.
right. They could be, but there's an example right there of an uncountable one.
Right. In terms of naming, we could call it, integer set. I mean, isn't it the case that
Really just not a set. A set to me conveys unordered.
Yeah,
Well,
I
wait a
mean, it would be an integer sequence.
Yeah.
well, I'm sorry, what's this?
Well, the sequence is conveying what I think Stephen's conveying with integer.
No, I didn't mean that. I meant integer set. What I meant was that the base assumption about the variables is that they're integers. I mean, I don't know whether this makes sense, but I mean, something like, is it the
That
case?
seems kind of horrible.
Why not just an
general?
I mean, why integers? If we're talking about lists, like it could be lists of anything.
Well,
Right.
yes,
I mean,
but
you could
as
have
you said,
then we're going to have complexes, and then we're going to have quaternion set, and we're going to have,
in all these
vector
years, we've
set.
never had a built-in. Okay, but the point is that this idea you said axioms and you meant it, because to set up this kind of implicit set, you have to have some base. I don't know, I'm using different words in different places here, but some base domain in which you're operating. And
Well,
I would
that's
think,
what separates naive set theory from set theory.
Exactly.
yeah, explain more in more detail.
I mean, in naive set theory, you can just say, give me the set of all x's that satisfy this. But basically, because of this leads to Russell's paradox problems. And so the solution is that you only allow yourself to build sets through, I forget what it's called in ZF. There's a name of the axiom. It basically lets you do set builder notation to say, give me all this, the set of all x's such, the set of all x's in this set. Yeah.
So Frankel choice axioms, ZFC.
Yes.
It's not choice. It's a
So
different one.
class builder was exactly the thing where you want to define a collection of things just in terms of a predicate. Just give me everything that satisfies some predicate. You have consistency issues with that.
Yes.
But fine.
Right. Hence, well, okay, but the main point here is that an implicit list set, whatever. I mean, the question of sets in general, we don't even have a notion of a thing you carry around that automatically, like an association, automatically removes duplicate keys. We don't have that notion for a thing that automatically removes duplicate elements. Or even that automatic.
The finite set, you mean?
Yes,
basically.
we don't have,
Yeah.
the other thing we could have is orderless list. And we've talked about having an orderless list.
Which
I
would
don't
be a
know.
multi-set.
Yes.
The orderless list and a version of list where you get rid of duplicates.
Yeah, I know, but the problem
Which
is
is
that,
distinct from orderless list.
indeed, that would be more like an auto-unioning list, otherwise known as a set.
Well, auto delete duplicates.
Right.
Well, I think it would also be
Union,
orderless.
like you said, is like a set.
Yeah, but that's yet a different case. Are you talking about the case where you delete the duplicates but you leave the order the same?
Yes.
Which is by the way what happens to the keys of associations.
Exactly.
Yes.
Although I argue that case is not terribly useful. I mean, I think the main case that people care about is the unordered sets or maybe unordered multi-sets. But if you want a multi-set, you can already represent multi-sets pretty reasonably using associations.
Right. I mean, I don't think, the orderless list concept has just not been a serious thing. I mean, people use union, they use delete duplicates, they use sort. It hasn't been.
If it was more efficient, I don't know. There have been plenty of times when, I'm not sure. I think there might be times when if it was significantly more performant in the same way that association is a lot more performant than lists of rules, then I think it might be useful.
But association has a lot of ancillary stuff, like the whole selector mechanism, all those kinds of things that are, like, for example, an orderless list. What happens if you ask for the 10th element of an orderless list? Does it just behave like an ordinary list, or does it do something different?
I would predict it has some ordering, like it has some canonical ordering or something, or maybe even an arbitrary ordering. But I think that the other problem with introducing a thing that's like a set would be that when we introduced association, there were some functions that returned lists of rules, and it was kind of like, well, okay, well, it's unfortunate, but there'll be just some functions that still return lists of rules. But most of the newer, most of the functions were, only came in afterward and returned associations, if you get what I mean. But here, there's a ton of functions that conceptually return sets that we already have, and we couldn't switch them.
Right.
Are these things like, I think orderless list and unioned list are more like data structures, whereas what we were using set builder for in the pure math packlet was just kind of symbolic representations for math. And these seem like two different cases.
Right. Yeah. It's not clear to me why we're discussing both of these things, right?
Well, because I thought that infinite lists, which are produced with a generator, are related to the set builder thing.
Well, there's certain, first of all, there's some countability problems. And second of all, there's the fact that, I mean, at least all the different, there are 5 different, infinite list things that have been discussed recently. But I mean, all of them, or pretty much all of them, it's kind of it's very constructionist. Like you tell it how to get the elements as opposed to giving it like a condition or something.
Are you thinking of like a sequence, like the sequence of f of n, where n is integers?
For what purpose? You're saying for the infinite list case?
Yeah.
Well, I'm saying, you can have an infinite range, and then you say select. You would say something like
Select a prime
range.
Q or
right. Well,
yeah.
right. There are
Range.
both, right? There's one where you can directly generate the nth element, and there's the one where you need to generate elements 1 through n-1 in order to generate the nth element.
Yeah, and set builder is more like generate the nth element directly.
Okay, but this
Wait,
is
in set builder you
But
don't
for
even
sets
know.
instead of sequences.
Yeah, I
What
mean,
do you
this
think
is both. I think infinite lists are really pretty distinct, both because they're kind of implicitly countable, and because I think this is much more of a programming concept for doing things like streams and stuff like that than it is a pure math concept.
okay. But I mean, okay, but this set builder thing, what does the pure math, wait, what is the pure math packlet?
That contains like the topology entity store and the other entity stores.
Which we should talk about and review sometime soon. I mean, I'm not sure what our strategy is in that area. Do we understand what it is?
Pretty much it's on hold.
Okay, but maybe we should discuss it and just see whether there's whether there's low-hanging fruit we can pick from it.
Could probably start by putting it in the packlet repository.
That would seem like a good thing to do. I mean, I'm pretty ignorant of what's there. And I mean, I don't know at what point the topology stuff that's there coincides with topology stuff that the computational geometry team is doing.
I think it's unlikely.
Okay. But I mean, I also...
Or just definitions and theorems.
Okay. Well, as we start thinking more about, find equational proof and theorem representations and so on, there may yet be some commonality there. I'd at least like to understand it. I mean, we have, hopefully in the next week or so, we have a thing coming up talking about category theory, representing category theory in the language. And I don't know how that relates to any of this stuff. All right, I think we're getting to be over time here. Let's just have a little bit of a look at what we replace.
Yeah. So the first one is poorly named, but it's basically a method of doing replace all with an exception pattern.
Why don't we give replace all an exception pattern?
Well, that would kind of be a natural place to do it if that's something we think integrates well with it. Do we want?
But isn't it essentially an except? I mean, on the left-hand side of the rule.
Yeah.
What's the difference between this? What's that?
Yeah,
It looks like from the example, it doesn't go inside of anything with head F.
Yeah.
Well, so that's more of a traversal order exception,
Yeah.
which could affect map and things like that as well. I mean, that's something we should discuss in connection with traversal orders, which is something we're talking about in this multi-computation thing, and we should have that, because this idea of a protected, protection from further traversal, which is what this is, as I understand it if I understand it correctly. I mean, it's similar to the excluded forms option in various mathematical functions, is it not?
I think we would do this by prepending a rule underscore f goes to itself, to the other rules.
Yeah, I understand. I mean, that seems a bit hacky, but yes, I understand that. But there's also the question of just saying for map, what should you exclude from the map? Because it's often convenient for code. I mean, otherwise you have to say if, for example, let's imagine that you could say something like map f over list with something like that. In other words, or for example, let's say this: map at level 2 with excluded forms failure. Means just don't do it if you run into that subpart of the expression. See what I'm saying? I mean, I certainly would have used this many times, but there may be a better way to do it. I mean,
all right. I mean, you can do that. Oh, hold on. This is map. Sorry.
you see, you
Yeah,
can't.
there is that thing. There is that thing. Maybe I should really look at this again. But there are those constructs. Let me see what they were called. That we talked about a year ago, and then a few weeks ago. That were sort of for dealing with kind of this case.
Where were they put? I mean,
Let me see. I'll get the information about them. But it was for, I think it was for kind of dealing with this case of if you kind of have one level of error propagation that you want.
Right?
okay, but the other possibility here.
Or something was one of we had a couple of, I don't remember the names off the top of my head. One of them I think was replace failure, and one of them was to extend missing queue with sort of more types of arguments or failure queues.
I think one thing we discussed was, I think, test applied, but that one we didn't come to any conclusion about. Yeah. So the idea is you'd give it a function and then you'd give it failure queue, and it would only apply it if it was not failure queue or something.
What about something like this, where you put a wrapper around a function and you say exclude from the traversal things that match that, that have that feature.
Right. So this is the same as the test applied, although it's more of a match applied. So basically what it would be, map wouldn't need any special behavior. And also you wouldn't put it around the list. You'd put it around the F, right? And all you do is this would be a function where it's the equivalent to if match q of hash, comma, the pattern, then hash, otherwise F of hash. I
know. That's what I was thinking here. And I agree that that's useful, but that doesn't do this thing about switch off the rodentification.
Yes, it does.
That would need special behavior in map.
Well, maybe in map, not in replace all, right? Because once you've replaced.
No, I agree. In replace all, it wouldn't.
I worry that adding something. I mean, I understand you're basically saying that you have an object that basically represents a list, but where you're going to ignore missing things in the list or failures in the list. I think there are two problems. The first problem is that the policy about whether you want to see the missings or not, that is a function specific policy, not a list specific policy, right? Some functions want the missing, some functions don't. The other thing is that I feel like whenever we introduce these sort of objects like that, the time it takes them to actually get supported in all the places that they need to be supported is long enough that it's a pain.
No, I kind of agree. I mean, look, I had a bug yesterday that was rather hard to find that involved position that had been going into, digging into things where I would have liked to treat as atomic certain aspects of those things.
Well, with position, I mean, Yeah, I mean, I feel like more often the problem with position is just the fact that its default is head 0 true level spec infinity, isn't it?
Yes, it is.
And that's, I feel like the most common case is actually the default for, I think count has the quotes the correct default, which is level
Count
spec 1
does,
head
yes.
0 false.
Right. What is this? Find expressions, find sub-expressions together with their positions. I see. What is this now? As a Nick production. Find all sub-expressions. Okay, find sub-expressions that match. What is this?
It's not the best of designs, but it tries to cover most of the cases when you want to restrict by both pattern and the position, and just
Oh, I see what you're
extract
saying. I see what you're saying. That's a okay. So that's a different. Well, it depends what you mean by restrict by position, because I mean the thing we're talking about with map is, look, the case with map is you hit a failure, you don't want to burrow inside the failure, or you hit some kind of object that you want to treat as atomic. It's kind of like.
This is only for level specs greater than 1, you mean?
Yes, that's correct. I mean, it's like, look, it would be treat as atomic anything with head H and don't go inside it.
Yeah, so in that sub-expression positions, that would be outer match except like H underscore.
What is inner match?
Underscore H.
Inner match means what's below you.
Inner
I see,
match,
so-
yeah. Inner match would be what below you, and outer match outside of it. So if you want to restrict going deep inside of something, then you make like an outer match except, so that it doesn't match anything inside that has this head outside, anywhere outside of it. So if
Right.
you all the positions inside failure would not be valid in this case.
So basically the idea is as you descend into an expression, stop if you fail the outer match. Is that right?
It's like you fail if like anything outside of this expression matches your pattern.
Yeah, I get it. But I mean, you could think of it as in the case of map. Okay, that's a different thing where you could say that's essentially, that is the analog of context quotes, context dependent patterns. So we could imagine something where we say, f of x blank goes to x squared, but only do that if the if there's no g anywhere higher up in the expression. That's the kind of thing you're saying, I think. So you're saying do a replace all, but with the constraint that that replacement is only done if there's no g anywhere higher up in the expression or something. Okay, there's more to figure out about this. This idea of excluded forms from map is something we should look at some more. And yeah, and I think it's time to wrap up for now. So progress is being made slowly. I'm excited that we seem to be re-exploring a bunch of language issues which have been long dormant, so to speak. So that's exciting as far as I'm concerned. All right. Well, thanks folks here. Thanks to folks on the live stream, and